All right, so let's actually look at how the production function is going to be graphed. So we're going to go ahead and look at how the production function is graphed, and we're also going to introduce this new concept called Tpp curve. So we are going to look at a hypothetical company. Let's call them Top Ag. So the Top Ag has actually charted the potential levels of output per day with the specific levels of labor use. And that's what we have over here on this chart. So, and that chart then corresponds to this graph. So the points on the graph, point A through J, are listed right here. We have the daily labor use, and this is in hours. So how many hours are we working people for that particular day? So start off with, well, we got one person working 10 hours. We've got maybe two people working a total of 8 hours each, so 16 hours. Then we jump it up to 20. And then we see the daily output level. So the daily output level begins at 1 unit, then it jumps up to 3 units, and then 4.8, and so on and so forth. So what we're seeing is that as labor increases, as we increase labor until we get down to this point right here, we're actually seeing that output increases as well, which makes sense. And then we'll talk about it a little bit later on in the chapter why down here labor, as labor increases, we actually see a decrease in production. So in this particular example, we're doing a single input to single output analysis. We're looking at just labor and how just labor affects the daily output level. So labor is the only input that varies. We are going to hold capital, we're going to hold management, and we're going to hold land the same in this analysis. So all other inputs are held constant. So we were just looking at the daily labor use and the daily output use. So if we took daily labor and daily output and we plotted just these 2 points, we're going to plot this input-output relationship, and it's going to look like this graph right here. So the graph is going to show us the labor to output from the table. A thing to notice is that labor is on this horizontal axis, whereas this output is on the vertical axis. So we're always going to put our inputs whenever we're coming up with this total physical product curve, because that's what we're dealing with right now. I mentioned that we're going to talk about the TPP curve. Well, what the TPP stands for is total physical product. So physical product is our output. So in this graph, we're looking at our total output. So output, another way to talk about output is physical product. And to abbreviate it, we call it the TPP curve. So in the TPP curve, we have our inputs down here on the horizontal axis, our output on the vertical axis. And we see that as the amount of hours that we use people, or the amount of hours that we employ our workers increases, what's happening to output? Well, our output is increasing until we get to this point I, and then it actually peaks and then begins to decrease. But knowing that the input belongs down here and output is over here is going to be an important aspect whenever you're graphing your own total physical product. So as we move along this graph, as we actually get up to this point of about point D, we see that we're actually increasing at an increasing rate. Our graph is increasing all the way until we get to point I, but it's actually increasing at an increasing rate until we get to point D. Then it hits this, what we're going to call it an inflection point. We're going to get into that a little bit more as well. And it goes up and it goes all the way up to point I. And from D to point I, it's actually increasing, but at a decreasing rate. Our total output is still going up, but it's not going up by as fast. The rate at which it's increasing is actually falling. Then we hit a peak at point I, and then it actually begins to decrease. So we're going to get into that a lot more, but just kind of a little tidbit into it. Think about this in your own operation of why that might be happening. And like I said, we're going to offer some more examples later on, but I want to give you this example right now. So let's say that there's only one person working, and that one person works 10 hours every day. Now, they could produce one particular good, one good per day. So you might think that's pretty good. This one person works all day and they get 10 or they get one product pumped out. Now all of a sudden, let's imagine that this one person, that instead of there being just one person, they're actually hiring a second person. And that second person, both the first and the second person now work 8 hours each. So have you ever been in a situation where you're working and then a second person comes and helps you and you start getting things done a lot faster? Well, that's what's happening here. Rather than there being just one person working by themselves, there's a second person helping them out. And then guess what? They only work 8 hours each day, so they're not quite as tired. Now, let's imagine that those two people are working 8 hours a day, but they hire on an extra person for that extra 4 hours to add up to 20 hours. Well, now they're getting 4.8 done, or 4.8 units done each day. And they're actually, by having a third person, they can utilize that third person for more help, and they're actually becoming more efficient. They're getting things done faster. They're quicker about things. And then they have that third person work an additional 2 hours, and then they start producing that much. And now all of a sudden you work 3 hours, or 3 people for 8 hours a day, and then an additional one for an extra 2 hours. So now we're starting to get into a point where that extra person and those extra hours are still beneficial, but they're not as productive, to where now we're still producing more because we have more help, but now maybe they're starting to get into each other's way a little bit, and they're not as efficient because they can't utilize their space as well. And then as time goes on, we're starting to see more of that. Even though as we get all the way down to here, all the way down to that point I, output is still increasing, we notice that people, maybe they aren't getting as much done per hour of work as what they would have up until we get to point D. So it was increasing at an increasing rate because we're utilizing more help. We're becoming more efficient with what we're doing. And then we hit point D and maybe we're starting to get a little crowded, but we can still get more done. And as we get a lot more crowded, more people, we're not using our resources as efficiently on a per unit basis, and we start to see this aspect up here to where work actually hits a kind of a plateau. And then what if we get down here? And maybe there's so many workers producing or working in such a small space that it actually, everybody gets in their way and we actually reduce production altogether.